Hello and welcome to the new lecture session. This Today we will discuss on a new topic that is called stratified charged engine. This is a top this is a topic another topic of modern vehicle technology. So students, let's start the today's class on basis of stratified charged engine. Basically, there are two types of IC engine. One is gasoline and another is a diesel, which are well established. However, each one of them has its own limitation. Gasoline engines have very good full load power characteristics, but have a rather poor part load efficiency. In case of diesel engine, it have good part load characteristics, but it has low smoke, limited power and higher weight to power ratio. The use of higher compression ratio poses additional problem of maintenance and higher losses in a diesel operation. For an automotive engine, both part load efficiency and full load power are very important because during the operating life of the engine, most of the time they work under part load condition. The maximum power is controlled by the speed, acceleration and the other characteristics of the vehicle. Therefore, Therefore, there is a need to develop an engine which combines the advantage of both gasoline and the diesel engine. At the same time, it should avoid as far as possible their disadvantages. Stratified engine is an attempt in this direction. It is an engine which is a midway between the homogeneous and the heterogeneous charge. Homogeneous charge basically means the SI or spark ignition engine, and heterogeneous charge means CI or compression ignition engine. The charge stratification means providing different fuel air mixture strength at various places in the combustion chamber. A relatively rich mixture at and in the vicinity of the spark plug, and a linear mixture in the rest of the combustion chamber. That is, the whole fuel air mixture is distributed in layer or strata of different mixture strength across the combustion chamber, while the overall mixture is rather lean. Thus, the stratified charge engine is usually defined as a SI internal combustion engine in which the mixture in the zone of spark plug is very much richer than that in the rest of the combustion chamber, that is, one which burns linear overall fuel air mixture. So student, the stratified charged engine refers to the working fluids and fuel vapor entering the cylinder. Usually the fuel is injected into the cylinder or entered as a fuel rich vapor, where a spark or other means are used to initiate ignition, where the fuel rich zone interacts with the air to promote complete combustion. A stratified charge can allow for slightly higher compression ratio without knock and linear air fuel ratio than a conventional internal combustion engines. So here student, here the picture show the theoretical efficiency of Otto cycle, diesel cycle and stratified charged engine cycles for the various mixture strength. The figure shows the variation of theoretical efficiency of Otto number 1, number 2 is diesel and number 3 is stratified charged engine for the different mixture strength under ideal condition. It can be seen that the part load efficiency of the stratified charged engine is much better than the gasoline engine of comparable compression ratio and almost approaches the efficiency of the diesel engine. However, it is to be noted that the diesel engine has a much higher compression ratio and hence has an advantage due to this factor. Thus, with the use of linear mixtures and a slightly higher compression ratio in a SI engine, a performance level approaching that of the SI engine can be achieved. So this helps to overcome many disadvantages of diesel operation. For example, a mandatory high compression ratio for better starting and good combustion over a wide range of mixture strength and poor air utilization are the main concern of the diesel engine. Use of higher compression ratio brings with it a host of problems. It involves greater maintenance, higher mechanical losses and higher weight to power ratio. The poor air utilization results in poor fuel economy and smoky operation at higher loads. So as a result mentioned here, another important point which is found from this picture, that is the limited range of a mixture strength, that is 0.8 to 1.2, which can be used for the gasoline engine or spark ignition engine. For the complete combustion, propagation of flame throughout the mixture is a must. In other words, only those mixtures through which flame propagation is possible can be used. In a single cylinder engine, a mixture strength below a relative fuel air ratio of 0.8 will be result is misfiring. For a multi-cylinder engine, this becomes 0.85 due to imperfect distribution among the cylinders. The maximum output mixture strength is about 1.05 to 1.1, where 1.2 for the multi-cylinder engine. Minimum specific fuel consumption is obtained at a relative fuel air ratio of 0.85 to 0.9, below which flame propagation becomes slow and cycle to cycle fluctuations occur. This limits the use of linear mixture and hence limits the gain in thermodynamic efficiency in SI engine. So students, from there we can understand the thermodynamic efficiency is increased in case of stratified charge engine. Here also reduce the air pollution too. In SI engine, higher hydrocarbons in exhaust are due to the flame quenching at the combustion chamber wall. If charge stratification is used, this quenching effect is drastically reduced. It is because almost pure air will be present near the cold combustion chamber wall at part low. So therefore there are the three distinct advantages of this using of charge stratification, that is no throttling losses, less prone to knock due to the reduced residence time under high pressure and temperature condition, and multi-fuel capability. Now come to the slide, that is history. The first attempts to obtain charge stratification engine was made by Ricardo in the year of 1922. So in the year 1922, the first charge stratification engine was developed by the Ricardo. The details of this engine are shown in this picture. Here, a relatively rich mixture was reformed at the vicinity of the spark plug. A relatively rich mixture which is formed at the vicinity of the spark plug and plug by an auxiliary spray, while another spray of fuel in the combustion chamber formed a linear mixture. So one is directly heated to the vicinity of the spark plug and another is entered the combustion chamber by the auxiliary spray. This arrangement could give combustion over a relatively wide range of mixture strength with overall very lean operation, giving efficiency as high as 35%. However, the range was limited at the higher speed. So, this is the history. Now, come to the next slide, that is Prechamber stratified charged engine. Later, Ricardo used a small Prechamber which is fitted with injector and the spark plug. The Prechamber after the Ricardo's design with the injector and the spark plug. In this arrangement, a rich mixture is formed near the spark plug by fuel supply from the injector. A carburetor supply lean mixture to the main combustion chamber. The auxiliary charge burns in prechamber and comes out through its throat into the main chamber and burn the linear mixture present there. Thus, a linear overall mixture can be burned. This approach involves many problems of engine operation, such as getting good performance at the full load operation, improper burning of rich mixture at full load due to the improper fuel distribution, and incomplete scavenging of the prechamber. And the last is loss of thermal efficiency. The loss of thermal efficiency due to the throttling. The next slide, Volkswagen PCI stratified charger engine. In this figure shown the Volkswagen PCI stratified charge engine. It consists of spherical unscavenged pre-chamber comprises approximately 25 to 30% of the compression volume. It is linked to the main combustion chamber by a relatively large pre-chamber opening through a flow passage. The main combustion chamber is disc-shaped. It has no squeeze surface, but a slight swell is induced by the intake port. The injection nozzle and spark plug are arranged in sequence in the flow direction during the compression. It is for the purpose of spark plug to receive a mixture of incoming air with fuel already displaced in air. This is expected to avoid over-enrichment at the spark plug. The total fuel volume is divided and is injected partly into the pre-chamber and partly in the intake manifold respectively. A relatively rich mixture is made available at spark plug under all operating conditions. Load regulation is achieved primarily by adjusting the mixture strength introduced into the main combustion chamber. The main advantage of this system is that unlike other stratification process, the fuel injection timing need not to be varied. This is a good simplification. The octane requirement is comparatively low, especially at higher speed. It can be easily operated on very lean mixture, which is also advantageous from exhaust emission point of view. So the next slide is Broderson method of stratification. Part load and full load performance of gasoline engine are not the same. There are two possibilities to tackle the problem of part load and full load performance. One way is to use fuel intake alone, fuel injection alone. Control the mixture strength in auxiliary and main combustion chamber by means of injection timing. Another way is to use carburation alone to obtain stratification with or without Prechamber. Here in this figure shows the Broderson method of charge stratification. It consists of an engine with a divided combustion chamber. The small or auxiliary chamber contains the injector, the intake valve and spark plug. Entire fuel is injected into the auxiliary chamber. At light loads, the fuel can be injected after the start of compression stroke. This is a situation in which the air is moving from main chamber into the auxiliary chamber. Almost all the fuel injected into the auxiliary chamber will remain there and will form an ignitable mixture near the spark plug. The main chamber will contain only air or very lean mixture. Due to the blast of flame from the auxiliary chamber, due to the torch effect, the lean mixture in the main chamber is burned. For rapid and complete burning of this lean mixture, the main chamber must be designed to ensure proper turbulence. This will enable mixing of the hot burning mixture coming out of the chamber with the mixture in the main chamber. At full load of the fuel is injected before the BDC, means that is during the suction stroke. It is intimately mixed with whole of the air, resulting in a mixture of uniform strength throughout the combustion phase. The flame produced by the spark plug will split into both the chamber, just like in a normal spark ignition operation. The Broderson method possesses the advantage of altogether avoiding the pumping loss due to the throttling. In addition, a higher part load efficiency due to the lean mixture and knockless operation at full load are achieved. This method also gives lower exhaust temperature compared to the conventional gasoline engine. The fact that at part load very lean mixture remain in the main chamber, emission will also be less. This type of divided chamber certification charged engine can be burned almost any fuel such as propane, kerosene, diesel or gasoline fuel. It has little sensitivity to octane. That is, it has multi-fuel capability inherent in it. So students, today we'll learn about the stratified charge engine definition, then its history, and Prechamber stratified charge engine, Volkswagen PCI start engine, and production methods of stratification in. On the next class, the next lecture session, we will discuss the second part of this stratified charge engine. So till then, stay at home and stay safe. Thank you so much.